So congruent figures are essentially the exact same thing as similar, with one very important difference. That difference being that the side lengths have to just be equal. So the scale factor between figures has to be 1. The symbol for congruent is a similar symbol over an equal sign. Okay? Now, once you know that they're congruent, the super nice thing is all of a sudden you know exactly what the side lengths are without having to do any multiplication. So here, this is an example of two congruent figures. It tells me they are congruent. So if A and E are in the same spot, I can say that angle A is congruent to angle E, which if you look here, that looks to be correct. We can also say that angle B is congruent to angle F, which looking at the figure up here, that looks to be correct. Angle C is going to be congruent to angle G, which again, if you look over here, appears to be correct. And last but not least, we've got angle D is going to be congruent to angle H. Now, because they are congruent, all of a sudden we can say their side lengths are also congruent. Just realized we put these on segments. So all of these should go here. We can do the same thing with side lengths. So the side lengths, we can say that line AB is in the exact same place as EF, so those will be congruent. We can do the same thing with side BC is going to be congruent to side FG. You can say that side CD is congruent to side GH. And you can also say that side DA or AD, they are the same length, is going to be congruent to side HE. Alright, I want you guys to try the exact same thing here. Write the congruent statement given the figures. And then we will meet back together on determining if polygons are similar, congruent, both, or neither.